Okay, looking at this problem, it says assume that 15% of the people are left-handed. If 6 people are selected at random, find the probability of each outcome described. And the first thing they ask is to find the probability that the first lefty is the 5th person chosen. So I want you to be careful when you read this, because it's actually combining both the geometric and the binomial. It depends which question you're looking at. It says assume that 15% of the people are left-handed. Well, right away you know your P is 0.15, and of course your Q is 1 minus P. So I just did 1 minus J3 there to get 0.85. But in fact, there is a fixed number of trials here. There are 6 people selected at random, so that's like our N. We can think of that as the N. But the first question, question A, is not actually a binomial question because they want to know the probability that the first lefty is the 5th person chosen. So because they want to know when will the first one occur, that's a geometric. And so we have a geometric. And when you see, when you know, you can recognize a geometric because it has language like until the first success. And so what you have is a bunch of failures in probability multiplied together until finally you get what you want. So the probability that x is equal to 5 is going to be equal to, all right, well, what will that be equal to? Let's do the computation. It's going to be 4 right-handed people. So 0.85 times 0.85 times 0.85 times 0.85, or 0.85 to the 4th power, times, finally, on the 5th person selected, you get a lefty, so times 0.15. We hit enter, and that's our probability rounded. And they want it rounded to 4 decimal places. So you can format this to show just 4 decimal places if you want. You might want to do it for a few of these. So, oops. I didn't want those all to be filled in there, so let me just clear those. Okay, now the next question says find the probability that there are some lefties among the 6 people. This one you're going to have to use the complement rule on. And the reason why is because it's going to be too tricky to, or what you have to do is you have to figure out, all right, well, what's the probability that sort of 1 in 6 plus 2 in 6 plus 3 in 6 plus 4 in 6 plus 5 in 6 plus 6 in 6. You have to do a bunch of computations there. There's kind of several ways that you could think about it, but I think the easiest way would to make this the complement, to consider the complement. The complement of some lefties is no lefties. The exact opposite. And so to find the probability that there are some lefties, all you have to do is compute 1 minus the probability of no lefties. Okay, so let me go back to this. I'll say that's just going to be equal to 1 minus the probability of no lefties. And no lefties is actually easy to commute because there's 6 of them and they're all not lefties. So that's 0.85, 0.85, 0.85, 0.85, 0.85, 0.85. So it's 0.85 to the 6th power. So we can compute this probability as being equal to 1 minus 0.85 to the 6th power. So remember, when you use the complement, you do that 1 minus to get the actual value, because a event and its complement add to 1. All right, now let's try part C. Part C says, find the probability that the first lefty is the 2nd or the 3rd person. Okay, these are 2 geometrics that you're going to add together. You want to find a geometric that if the first lefty is the 2nd person, then you want to find the probability that the first lefty is the 3rd person. And both of those are geometrics, and then you add them together. So you're going to do probability that x is equal to 2 plus the probability that x equals 3. And why are we using the geometric? Well, because it says the first lefty is on the 2nd or the 3rd person. So either one. Here it is would be on the first lefty would be on the 2nd, and then probably x equals 3 would be the would be that the first lefty occurred as the 3rd person. So then what you do here is you say equals, and let's see, if for it to occur on the 2nd person, we would have a righty 0.85 times on the second person, you get a lefty. Okay, so that's a probability that it occurs on the on the second person. Now we're going to add to that the probability that it occurs on the third. So that's going to be a righty, and then a lefty. So 0.85 times 0.85, which you can just say 0.85 squared, and then times 0.15. So then you get 0.2359. If you and you can adjust this so it rounds to 4 decimal places if you want. All right, D then says, find the probability that there are exactly 2 lefties in the group. Okay, exactly 2. This 2 of a 6. So this is definitely a binomial. And when we want exactly, we use the command, the last argument, 0, as the last argument. The last argument. If you want to accumulate, then, up to a certain amount, then you put 1 in as the last argument. So what I mean there, that's in the command. So we want the probability that x is equal to 2. So you'll come up here. I'm just going to go into a cell, like just the cell here I'm in, J something. I can't see it because the screen's up. But anyway, I'm going to go up here, and I'm going to say equals. And then I'm going to do the binomial distribution, which is right down here. And it has 4 arguments. Number S, the number of trials, the probability of S, and whether you want it cumulative or just right at the moment, which we just want right at the moment. Okay, so the number that we want is 2. That's the number S. So that's 2. The number of trials are 6, because we're selecting 6 people at random. The probability of S is 0.15, and no, we do not want to accumulate, so we put a 0. We hit enter, and that is our probability. 0.1762 would be rounded to 4 decimal places. Okay, E then says find the probability that there are at least 4 lefties in the group. Okay, when you see at least, you want to use the complement. So the complement of well, there's 2 ways to do this, but I think this is the best way. At least 4 is 3 or less. And you can accumulate up to 3, but if you wanted to do 4 or at least 4, you could do x equals 4, x equals 5, x equals 6, and add those up as individual binomials. Or you can do 1 minus the binomial distribution where you accumulate up to 3, which I think is a little bit cleaner way to do it. So we're going to do the probability that x is, really we need greater than or equal to 4. I don't have that symbol on my keyboard, so I'm going to do it like that. That's going to be equal to 1 minus the probability that x is less than or equal to 3. Right? So what is the function? You're going to say equals 1 minus, and then you type your binomial distribution in. You want to go up to 3. Comma, out of the 6 trials, the probability is 0.15, and then we want to accumulate that up, because what that's going to do is it's going to give you the probability of none plus the probability of 1 plus the probability of 2 plus the probability of 3. If you add those up and subtract it from 1, you're going to get the remaining, which is that there's 4, 5, or 6. Okay, and then you round that to 4 decimal places. And finally then for F, find the probability that there are no more than 2 lefties in the group. That's just straight binomial, and that is the accumulation up. So that's going to be the probability that x is less than or equal to 2. That's just accumulation, and so you'll just go equals and then binomial distribution, which is right here. And how many do we have in it? We want to have 2 out of the 6. And then, or we want to have no more than 2, and then 0.15. And the way we know that we have no more than 2 is we do 1 there to say that we want to accumulate. So we're okay with it being 1, or 0 lefties, 1 lefty, or 2 lefties. We want that total probability of those 3 things. You hit enter. Okay, and so 0.9527. All right, hope this straightens some stuff out for you.